Welcome to the Radical Ingenuity Group Hazardous Location 101 series. My name is Mark Temple and I am the Principal Consultant here at RIG in Houston, Texas. I have over 30 years working in industry, with a large portion of that spent working in hazardous locations. So for a lot of people in the industry, the link between engineering installations and explosion is not at the front of their minds. It's an unseen hazard, unlike a rusty tank or pipeline. It's obvious as you're walking past. In some areas of the world, it's not even seen as a specialty, competency, equipment just installed by a person, they're decompetent. Imagine your 5-minute oil change tech changing an engine blade on a Boeing 777. They're both mechanics, right? Electricians are the same, right? No. If you're connected to anybody working in oil and gas, you'll know about explosion risk. My LinkedIn feed is full of news about explosions. Explosive atmospheres actually cover most industries, but it's just not so obvious. So we have medical, fast-moving consumer goods, painting electric vehicles, refueling jet fighters, even air conditioners are now filled with propane or isobutane, because it's more environmentally friendly, low global warming products. So if you see an HVAC tech with a blowtorch doing some maintenance, just tap him on the shoulder and make sure that he knows, because that is a big change to that industry. After a major explosion, root cause analysis is not easy. Imagine working backwards to the ignition source on Deepwater Horizon. Or Piper Alpha, it killed 167 people in the North Sea. We don't have NASA level control architecture to analyse. The digital AI machine learning world is not here yet. We might do another video on that. So for Deepwater Horizon, regulators had different views on the root cause of the ignition source. One said it could have been explosion protected equipment. One said it was definitely the engines went over speed. At the end of the day, it was an ignition source, whatever you call it, and that's what we need to zoom out to, rather than zooming in and just saying, a box needs a label or a glick cable gland was wrong. The reports are very interesting read, available on the Bessie and the US Coast Guard sites. The Chemical Safety Board had a good review as well, but didn't focus too much on the ignition source, much more about keeping the genie in the bottle, i.e. asset integrity and all the controls around that. I want to read a couple of comments from the report from Deepwater Horizon from the US Coast Guard. So as I said, these are publicly available. Explosion. The exact location of the ignition sources or source that caused the initial and subsequent explosions and fire on Deepwater Horizon cannot be conclusively identified. A number of possible ignition sources may have been present on the module, the most likely of which are electrical equipment on the drill floor, in the engine rooms, or in the switchgear rooms. The classified electrical equipment installed on Deepwater Horizon at the time of the incident may not have been capable of preventing the ignition of flammable gas. Previous audit findings showed a lack of control over the maintenance and repair of such equipment. Therefore, it cannot be determined whether the classified electrical equipment was in proper condition. The 1989 International Maritime Organization (IMO) Mobile Offshore Drilling Unit Module Code is insufficient because it does not have clear requirements for the long-term labelling and control of classified electrical equipment, nor does it establish requirements or guidance for the continued inspection, repair and maintenance of such. Still a gap today. So we have different views on what happened, root cause analysis, functional safety, blow preventer, bent pipe, etc. Different views across industry, all correct, no argument. If we keep that genie in the bottle, if we keep the gas in the blow preventer, etc., everything is fine, will be better. Gas in pipes, etc. From what I'm seeing, it's worse than ever. Asset integrity is a major concern, and it's the cycling of people through the industry with that domain expertise going out, new people coming in, and it's been like that for many years, but we don't carry on the lessons learned in some instances. my aim is to get everyone thinking ignition source management rather than EX, HASLO, intrinsic safety, all these generic terms that zoom in on the products. That's just the nuts and bolts and mandated systems. It's not managing ignition risk. So how do we manage ignition risk? It's, there's a common rationale. It's not mine. It comes from various government guidelines. You'll spot it as you read them. They've been around a long, long time. This is not new. It's just a reminder. But really, really powerful and really gets you thinking. If you think this way, when you work with a capital project, things might go seamlessly better. So we have substitute, control, and mitigate in that order. You'll hear people on LinkedIn, the noisy people, talking about mitigation all the time. Mitigation is the final step. Substitute control, the things that we do in the engineering world should allow us to fix a lot of things before we need mitigation. There's much more to the story than just mitigate. So if we talk about ideation, we talk about process and engineering ideation and design. So we ask ourselves, can we substitute any risky items for something else, a non-combustible system, substance, different way of containing that system, different design of pipe work, less flanges, less joints to go wrong, therefore not creating a typical zone 2 environment. We put an engineering control, and then maybe mechanical designer may not think of that. He may think, well, that's a perfect place to put a joint to maintain it, but it might be above a massive ignition source and you wouldn't know, potentially. And that's why it needs to be a key part of CapEx review. Move the ignition sources away from the release point. Big oversight, seen it right through my career. If we'd put 10 feet more cable in, it wouldn't have been in a classified area after it's installed, typically, etc. It sounds simple, right? But not a lot of it seems to go on. It's more like, oh, there's a release point, right? We need to put $3,000 worth of explosion protected equipment by it because there's a potential ignition risk. So ignition source review should be part of a capital project, value engineering, maintenance engineering, whatever reviews we need. So that's the substitution part, so that's the front-end engineering design part, if you like, that we can work with. Well, then we get to the controls. So we can't move it, we can't do those controls, so we've worked out that the equipment has to be in a zoned area or a classified area. So can we change the type of equipment to be less maintenance intensive between these types? So we'll talk about these in a moment. Can we install an active passive system to prevent ignition, shut down, or on gas detection, for instance? A stacker trucks, forklift trucks use both systems. So one of them drives into a hazardous area, detects gas, shuts down. The other one is completely engineered to be able to drive through. Functional safety, big subject. Engineering controls, automatic, mechanical, electrical, to stop things, getting out of control. Safe systems of work, lockout, tag out, things like that, procedures. They're all engineering controls we put in place. Robust supervisory SCADA systems, DCS, etc. To make sure that actively tested, cause and effect, and make sure these things don't get out of control. And then when we've tried to move it, we've put engineering controls in place, and there's still a residual risk, we have to look at mitigation. So this is the final point that everybody jumps to. So training is a key one, competency, signage, PPE, exclude people from the area, barriers, alarms, inspection and maintenance procedures. All of these things are the things that we can do without engineering controls to lower the residual risk. So overview there of what we should be looking at with projects. When we zoom in a bit about products, a lot of people get interested in that bit, and we'll talk about that. This is the Radical Ingenuity training bay, by the way. This is the IECX and ATEX one. We're building an Article 500 and 505, and we also we're building an industry 4 training rig, because you know, us old guys with the grey hairs know how the operational technologies work, and the IT guys, you know, we need to what we call bridge that. So that's what we do. Okay, I'll move over to the inspection. So, maintaining the controls. The work involved in maintaining the ignition source management ecosystem, if you like, once set up competently, is not difficult. It is time and effort, which, you know, and it is competency based, as we talked about. So we need to be aware of that. Engineering design can help massively. We talked about relocated equipment. But another review that needs to take place is the Hazardous Location engineering review, as we alluded to, is siting the equipment, maintainability, etc., etc. So we're going to do an example, practical example. Assume this data plate is all good. Imagine this box with more bolts in. Imagine the data plate is all good for the area. The engineers have fixed all that, right? We've got this right. Actually, this data plate is not right for this location, but that's part of one of our assessments. There's no ingress protection on this box. This is a flame-proof box or explosion-proof box that's just metal to metal. So the ingress protection rating is literally that metal to metal joint. There is no seal, IP seal. So we have this nasty fabric tape that goes around. It's the worst thing in the world. If you go within 10 feet of it, you get dirty. Really good quality methodology for keeping water out. But top tip, buy these with a seal in and maintain the faces with the appropriate grease. So, we've got our permit. We've got a permit to work. I've got a method statement here the boss has given me. It's locked out, tagged out, isolated. I have gloves, I have light eye protection, and we're going to do an inspection. Now, if this was in a hazardous area, we might want to look at a hot work permit to do the check for dead testing and things. But we'll push forward. We're all good to go. We know it's isolated. So here's my permit. So we take all this nasty tape off. Yeah. Make sure we don't lose any bolts through the grating. I'm going to cheat for speed. You don't want to be there all day with me. This is, imagine doing this by hand. So you know this has got a hinge on, some of them don't, so this face plate may drop. Make sure we don't drop those bolts. So we need to make sure of that. Some boxes have a jacking point with a threaded hole in that you can use that's designed in to prise the flange open, because these get sticky and rust together sometimes. So you see it drop there. So there we are, that's the first stage of opening the box. It says remove tape, make sure we don't lose the bolts of the grating, and then now we're on to checking the faces. Let's have a bit of a deeper look at this box. So I've got a permit, so we're going through it. We clean up and maintain the box as per the OEM allowances. So this is very clean looking. You can see some marks on the face here, around the edges. Don't look too bad, but if it was at me, I would be contacting the box manufacturer and double checking to see whether this mark is okay, whether it's a critical part of the flame path, whether there's any cleaning up that we could do. With any EX product, never assume what you can and can't do. Always default to manufacturers, because it's the manufacturers that have spent all the money getting the equipment through the test labs, to get certification, so they know their products better than anybody else. So yeah, I would check these. Obviously we would do any repair. Another tip is, if you're ever doing any work on these boxes, is cover these flanges. Put some painter's tape, masking tape on there. This one came with that. As soon as this came out the box from EXP, it was all protected. Thanks to EXP Controls for providing the box. Yeah, so clean it all up, put the tape on, do the repair, and if it was a repair at all involved with changing some settings or changing the relay out, it's always a good idea to do an EX inspection check sheet, because then you can get the credit for doing that for your computerized maintenance management system, the RP, etc. So once we've done the repair, we re-grease the flange. This, you notice this hasn't got the seal. Again, many discussions about what type of chemicals you can put on this face: copper slip, Cuprasil, all the brand names, silicon, non-setting, manufacturer's instructions every time. It will tell you. And nowadays, it was difficult for us back in the chemical plants in the 80s. Now with the internet, instructions are never far away. So check all that, re-bolt it. This is something that people miss quite a lot. These things are feeler gauges. So when you bolt this back up, there's a designed-in flame path here. This is a gap, and this needs to be maintained. Now, people will tell you, torque it. The rules for IEC equipment is actually tool type, so as long as nobody can do it with their hands. But we want to make sure that flange is not got a gap. So it may take some torquing down of these bolts. It may be that people say as long as it's torqued, it's fine. It may be warped. Over the years, I've seen every permutation of this. People have had cork gaskets in there that's deformed the face. All sorts of things go on. Yeah, re-torque to make sure that we're not over that maximum experimental safe gap for that gas group. And then we stick our tape back on. So straightforward, right? Okay, imagine this box with more bolts above a high footfall traffic area, on top of the stairs on a land rig, 100-foot drop just to your left, people in and out, just handrail fall, step ladders moving in and out. So a designer in Houston has put the reset for the AC unit for the doghouse in that box, in that area. It's in the C1, D1 area. The rig is located in India, 40 degrees heat. The AC unit wasn't spec'd right, so that's tripping all the time, day and night. The electrician's getting woken up in the middle of the night, go out and reset that trip. Nobody else is competent to do it, yeah? How many times do you think all the bolts go back in when it's been tripping all night? Hundreds of times over several weeks. I'm guessing the third time. The third time, the guy stops putting the bolts back in, and that's how I found it. I found it with one bolt in and then started asking questions as to, why do we not bother putting bolts back in? They weren't lost, they could have been lost, but it's part of the problem. So the interesting thing about that, just to touch on that, is those bolts are designed for that box. Again, manufacturer's instructions, if you need to replace it, keep some space. So you could say that it's a human factors issue. That guy was not wanting to go in and out and day and night, but and if something went wrong and exploded, potentially that's the root cause it would come to. I'm saying it's engineering design as a root cause. That AC trip did not need to be in that location, in that box. It could have been somewhere else, accessible, without footfall, etc., etc. Part of the engineering front-end design review. So let's wrap up with a couple of points here. Let's all talk about ignition source management rather than zones, classified areas. To coin a phrase from my teenager, it hits different. That comment probably won't age well, but we'll give it a go. So let's look at each element of ignition source management and compare the hazards similar to a naked flame. Yeah, could be. Imagine a naked flame inside of that. The likelihood of ignition is probably less. Yeah, and that we will struggle to justify that in any forum, but the impact is the same. ignition, gas release ignition, major catastrophe. Any risk assessment would kick that straight out. I've done it before for stock cards when particular companies, managers have said, oh, it's only a box. It's like, right, do you want me to put a risk assessment stop card in for it? Like, yeah, we'll manage it that way. Impact, likelihood high, impact catastrophic, always gets people's attention. Let's not forget past lessons learned. We do seem to do this all the time in our industry. IoT and digital is not going to fix this one. It's actually going to make it more intense, more effort, new players, new equipment, more ignition sources. But get people involved early, and you'll reduce a lot of the risk, a lot of time, because we're not fixing things, we're preemptively managing this, and a lot of expense, because we can maybe redesign a system, help you out, select technologies, locations, bigger picture stuff, zoomed out, to give you that full ecosystem approach. But the rise in incidents is shocking. Just have to look at the Gulf Coast here. We've killed several people in the last few years. It's not good. So if you need help or advice, it's out there on any aspect of industrial technical compliance. If you want to take a step into digital, we have a network of 100 plus consultants of all expertise. Please reach out. It's radicalengineering.com. My name is Mark. There will be more content coming out. This is the first of many. Just want to give you a high overview of ignition risk rather than zooming in on data plates and boxes and things. Some exciting stuff on the board here. We have a industrial PC that's hazardous location approved. We have some tests going on with some inspection and some installation issues. Stay connected. We do a PowerPoint free hazard training here as well, or webinar, which we can extend to you guys. And thanks for sticking with us.